Thank you for joining us today. So please mute yourself and save your questions for the end, so it's easy to watch on YouTube. And for those of you who are first time with the serverless Toronto group, we started as a regular function as a service developers, but very soon we learned that we help businesses by working smarter, not by sprinting fast in Scrum terms. And we started defining serverless not as a tech stack, but as a pragmatic mindset, as a way to focus on business value. And I know that sounds fluffy. So in simple terms, it comes to how you triage problems. So in general, if the platform has it, you're going to use it. If the market has it, you're going to buy it. And if you can change the requirements, you do it. But you have to build it, then you own it. And this broad definition of serverless allows us to explore various IT topics. So if you go to our YouTube channel, YouTubeserverlesstoronto.org, you will see like almost 7 years, more than 7 years of different videos that we recorded. Not all events were recorded. And I'm happy to announce we already negotiated 2 more meetups. A month from now, we're going to have a meetup about Postgres. It's surprisingly good for more things than standard relational database. And then if you remember, Dan Dobrin spoke to us before about serverless Java. He recently spoke at Google Cloud Next event, and the event wasn't recorded. So it's really good. It's about A2A protocol, agent-to-agent protocol that builds on top of MCP. So I'm excited about that one. We have one of the rare stages that we'll be talking about these events. And if you have non-altruistic topics that you would like to share with the community, please reach out to John and me, and we'll pencil you in. And then last but not least, thank you, Manin, for being a sponsor like half a decade now. We do these surveys at the end to help us be better. Normally, you have to do the survey in order to win the prize. Now I'm just asking you to go to bit.ly/SLS TO to help us improve and what topics to bring to you. And we have 9 free titles, and whoever doesn't win can use a 45% coupon that we got from Manning here. And I like to start meetups by explaining why this topic, why this session today. So LLMs are not deterministic. So building on top of them often feels like trying to build a house on jelly, and the ground wobbles underneath you. So this explains why too many AI proof of concepts never make it to production. And we need to help one another to share experiences and approaches that work and mistakes that we made. And this reminds me a lot of the early serverless days when serverless was just becoming popular. And AWS created This Is My Architecture video series, where developers share their successes and serverless architectural patterns emerged. And so we need something similar in the LLM world. And that's why I was excited to discover this book for Manning Enterprise RAG. And it caught my attention, the approach to using Azure AI Search in the architecture. But they got me at the chapter 2 title, Nothing Happens Until Someone Writes Evals. Which like we covered that in previous meetup, but it's important to reiterate that importance. So by sharing our own experience, we can help one another build more reliable system. And Tyler Darshil, thank you so much for accepting the invitation to walk us through your book and share your work. So please take it away. I'll stop sharing.
All right, thank you for that great introduction, Daniel. My name is Tyler, and I am here with my friend Darshil. And we're going to talk to you about our book called Enterprise RAG, Retrieval Augmented Generation, and how to scale it. And the title of this talk is RAG Done Right. So I'm going to slideshow. And that's the title that Daniel came up with. I think that's pretty clever. All right, so I currently work at a Fortune 500 company. It is over 100 years old, and it is on the East Coast. And they make aircraft parts like hoses and valves, etc. And what you do right now is if you call their customer service before I work there, you would ask them, what is product XYZ? And then the representative has to search through 100,000 PDF pages. Then they have to search through 10 or more huge databases with millions of records. And then they might be able to answer within 5 minutes. So what I did is I built a chatbot where instead those customer service representatives can ask, what is product XYZ? And then the chatbot searches all of that data, and it can answer in 10 to 30 seconds. And it doesn't just pull up the data, it pulls up like a well-worded answer as well. So we have a 90% 5-star feedback rating from our users. We get one complaint every 2 weeks, and it is almost always the user's fault. The user will say things like, it was wrong about this thing. And then I'll check the data and I'll say, actually it was correct. And they'll be super embarrassed. They'll be like, oh, I'm so sorry. And that was really rewarding for me to get to that place, because when I first started, I was the one making all the mistakes. The AI was making all the mistakes. But after, months and months and over a year, the AI was not making any mistakes anymore. The humans were. So my role was, I wrote every line of code, and it took me 1.5 years to build, and I failed 5 times for every success. I would try 5 different products or searches or different things before I found one that actually worked. So it was a little bit frustrating, but we got through it. So now I'm going to share with you, and in the book, I'm going to share with you what I did. So the first thing that we did that really worked was agents. Instead of just having, just sending the question to an AI and getting an answer back, we started using AutoGen agents, and that really improved the quality of the answer. So here's kind of a triage thing. The user asks a question, and then it goes into this question triage, which is another LLM. And it says, please categorize this question as a product search or an order search, or if it makes no sense, then please ask the customer for more clarity. Ask that customer, say, I'm sorry, I don't know what you mean, because people will ask very strange questions, and then they'll blame the chatbot for not understanding them. So here's an example. What is product XYZ? And then the question triage would say, okay, it's a product. And then so we would search using the product search agents. We would not search using customer order search or to clarify, because that would waste tokens, and it can get expensive when you're scaling up. So we used AutoGen agents. With AutoGen version 0.2, we had to use 2 agents for each search function. So we had this search assistant agent, which suggests the search term to search for. And then we have the search executor agent, which actually calls the search function. And then when the search function returns information, that is the search results, and then we write an answer using those search results. So here's an example. We ask, what is product XYZ? And then the search assistant agent says, bro, you should totally search for product XYZ right now. The search executor agent says, okay, I'm going to call this function. And it does, searching. And then it gets these search results. Name, product XYZ, price $3.50, weight 2 kilograms. Right, so this is what it looks like, very simply. You got the user question and chat history. We have to put the chat history in there, so there are like non sequiturs, like if a user says, how much does it weigh? Then the AI is going to have no clue what that is unless they look at the chat history. Then there's group chat manager, which is, you kind of bundle these two. You bundle the search executor agent and the search assistant agent into one group, and you put that under a group chat manager. And then we already talked about the search function, and all of these return search results. That's their goal. And then we have a final agent that writes the answer, and that gets streamed to a front end, so users don't have to wait a long time. It appears like word by word, like product XYZ is this thing, and it just writes it as you're sitting there, because it allows you to see it faster rather than waiting like a whole minute and then this big wall of text popping up at you. It does it like word by word, and that lets users see a result faster, or at least the start of a result. Okay, now this one is a little bit more complex, but it's basically just this same diagram duplicated. So instead of just one group chat, we have 2 group chats. And this is how we pull off searching multiple databases at once. So like we search 10 databases at a time. How we do that is we have, for each database, we have a search function, a group chat, and search agents. So we have 10 different databases, so we have 10 different ones of these. And then all the search results get combined at the end, and then we have one writer agent, which writes about those answers. The second thing that we did that really helped us out was a search. If you look at tutorials, a lot of them will say you gotta use a vector database. Most of them will say that. We tried something else. We tried using search as a service. We tried using Azure AI Search, and it was very accurate. We always get what we need in the first one or two results. It's fast. For each database, if you have around 1 million records, it'll take 1 second. If you have 10 million, it'll take 10 seconds. And it scales up really well. We currently have 50 million records with embeddings. There are some other options, though, if you don't like Azure. There is AWS OpenSearch, Google Cloud Platform Vertex AI Search, and Elasticsearch or FAIS, or Facebook AI Search. The third thing that I learned that is surprisingly important is communication. It is really important to communicate to stakeholders and to users exactly what your AI can do, because most people don't understand RAG. They don't know what it is. They've heard about AI. They've heard that it can do magical things. So they're going to expect that AI to give them a perfect answer every time, even if they give it a bad prompt. They're going to expect the AI to be able to read their minds. So you have to, as quickly as possible, dispel that illusion and let them know exactly what your chatbot can and cannot do. So first, we start out with evals. That's chapter 2 of the book. The reason why we do evals, an eval is a question and answer pair. It's like, what is product XYZ? Product XYZ does this. And the reason why we do that is because it gives you simple goals and it allows you to communicate expectations with your boss, because your boss might have some expectations that they're not wording to you. And also it protects you from criticism later on. So here's an example eval. What is product XYZ? Product XYZ is a toaster for meat. What is product ABC? Product ABC is a toaster for fingers. So just simple question and answer pairs. And why this is helpful is it takes you from, I need an AI that knows everything, to I need an AI that knows specific information. And then you can find out which databases have that specific information. Also, this helps you, it helps your bosses get aligned, because you're probably going to be working in a company where they just say, hey, put AI into our company, and they don't know what AI is. And this helps them to understand what you're doing and agree on it. So you can get aligned. It also gives you protection. This happened to me. So one of the stakeholders, one of the people who was championing this project said, I asked the chatbot for our accountant's phone number. Why didn't it have that information? And I said, employee phone numbers were not in the evals. I can add that info, though, if you like. And this protects you, because the evals are kind of a contract that you have with your boss, saying the chatbot will be able to answer this kind of question. And if it's not in there, then you say, I'm sorry, but we did not talk about that. If you would like me to add that, then I can. Okay, so another really important thing is to communicate with your users. And I choose to do that by a disclaimer message or a user manual. You say exactly what kind of data your RAG can search, what it can and cannot do, and how to use it. So like our disclaimer message will say, I can only search these databases, and I can only search them in this way. Please use full sentences. Don't just give me like a random number. And people don't listen, right? They'll still give it just a random number. But then when they complain, I can revert back to the disclaimer message. And I say, as it says in the disclaimer message, which you read every time you use this, you cannot just enter a number. You have to use a full sentence. So here's an example of a disclaimer message. Hello and welcome to Search Chat. I only have access to product information in our hoses and valves databases. I can only access 3 product records at once, so I cannot tell you how many products we have or give you their average price. Please talk to me in full sentences, like how much does product XYZ cost? And that really helps, because, like I said, some people have these preconceived notions going in of what AI is, and they don't really know what the limits of your system are. So you need to tell them upfront. So here are some bad examples. These are all completely based on factual reality of things that actually happened to me. One user was angry because he said, everyone in our department knows that product ABC is more popular than product XYZ. We just put out an ad campaign for product ABC. Why is the chatbot recommending product XYZ? And my response was, hello, thank you for providing feedback. Right now, the chatbot can only retrieve data from the specific databases. I don't see any information on product popularity in there. Do you know where I could find it? And they didn't respond to this because they realized, oh, if it's not written down, then the AI doesn't know it. Like there was one guy who made fun of my AI because it didn't know tribal knowledge or things that's not written down, but that people in the department just somehow know, even though they haven't written it down somewhere. So you got to make it clear that if it's not written down, your AI does not know it. Here's another one. User wrote 614-234-698. And the user gave me bad feedback, 1 out of 5 stars. So Daniel, 614-234-698. What is your response?
Phone number.
Yeah, see, yeah. I mean, it could be a phone number. So Daniel doesn't know what to say in response. A person wouldn't know what to say in response. Like Daniel, if you just texted me or if you called me and you said 614-234-698, I would think you're crazy. I would say I don't understand what's going on here. And that's the same thing for an AI. If you just put in numbers, it's going to say I don't understand what's going on here. And so it didn't give them the right answer because it couldn't understand the question. So then my response was, thank you for providing feedback. As it says in our disclaimer, the chatbot needs you to use full sentences. Otherwise, it won't know what you're asking for. Try, what is product 614-234-698? And here is another example. How much is wrench 423? And the user feedback said it gave no useful answer. And I said, as it says in our disclaimer, our chatbot only has access to hose and valve databases. We are planning to add the wrench database feature, but we have not done so yet. So people will sometimes ask for products that we have not hooked a database up to yet. So like there's a database, with products that we do not support yet, and people will ask for that. And that's when you need to talk to your managers and decide, is it worth hooking this database up? Is it going to be a huge pain in the butt? Is it going to cause too much overhead? Is it going to cost a lot? Is it going to slow down everything else? And how often do people need to access this database? There was this database that it took me a month to integrate, and then I found out nobody was using it. So that was a little bit frustrating, but it's a good thing to learn, the give and take of that. So Darshil and I are writing a book. The first 4 chapters are out now on Manning Early Access Program, and it teaches you how to do all this. And you can follow me on LinkedIn for updates as well. My name is Tyler Suard on there, TYLERSUARD. And now it's Darshil's turn to talk. And if we have some time afterward, then I'll show you guys some example code that will be in chapter 5.
Thank you. Thank you so much, Tyler. It was great. Uh, okay. So Daniel, should I take over or do you want to chip in?
So what is the question?
Do you want to add anything or should I continue?
No, it's amazing. So let's make it easy for people watching on YouTube.
Okay, gotcha. All right. Thank you so much, Tyler. I think what Tyler went through is really amazing in terms of what enterprise RAG is all about, and I think he talked a lot about the questions and the problems that we usually face while building RAG system. And now, what I'm going to do is I'll quickly browse over few chapters from our book and give you a brief intro about what this book contains and what are the few techniques or tricks that you can use to build enterprise level RAG that can actually work in production. So let me go ahead and share my screen. All right. I hope my screen is visible. All right. Okay. So yeah, starting with this is a mental map that we have in our book, which talks about different stages of RAG. As we all know, RAG stands for Retrieval Augmented Generation. So what it usually does is let's take a step back first and identify what we used to do before RAG came into existence. So when ChatGPT and tools, other LLMs came into the picture, we were very excited to give it a try. And what we used to do was we used to ask a question and it used to come up with an answer. And then people wanted to make it more personalized. So we come up with something where we can provide a context to the LLMs so that it responds in a way that satisfies the context, or that basically answers in a more customized manner. And that's where we started providing context. Now, someone wanted to automate the entire flow. So they came up with RAG, which what it does is it usually fetches the context first from the large data pool that we provide, and uses that information as a context to pass to the LLM and generate an answer. That is why what we do is we retrieve first, we augment it, and then we generate a response. So the three steps are ingestion, where we kind of ingest our raw data into the system so that it can be retrieved later. And then we do some kind of pre-processing on it, whether we use some kind of services like Azure AI Search, or we do it all of it manually. And then what we do is we embed it somewhere into a vector database, or the managed search service manages it, and then we make it searchable. Now, what happens is once the data is ingested and it's time for retrieval, we kind of run this loop where we take in the user query. And very interesting point that Tyler brought up was that users don't know what to ask, right? So it is very important that we convert the user query into something that makes our system more enhanced. So basically what we do is we convert the user query into a search query by rewriting it. So there are a few steps that we do. First, of course, is the input validation, so that we can avoid things like when Tyler showed some random number, user asked some random number. So those kind of steps can be eradicated at the input validation point itself. Then we move to a query triage. So query triage is nothing but kind of an agentic system where we redirect our rack system to search for a particular data source. So let's say you have 10 different databases, or you have 10 different data sources, and you only want to search for a particular database, or you only want to search from a particular set of documents. So query triage is the point where you kind of redirect your system in which direction to move forward. And then we rewrite the query for that particular query triage, and then we pass it on to our search agent, from where we can search for those documents. And once we have those documents ready, we have that relevant chunks of information which can be used as a context. We pass it on to LLM to use that and generate an answer. Now, since we have already reached to the point of agents, I'd want to dive a little deeper into the agents. So, these days, everything is getting converted into an agent. So, what agents usually mean is that we are not just stopping at the generation, but we actually want AI to take an action, to decide a course of action after generating a response. So let's say, for example, we ask AI to summarize something. Let's say we pass on our sales report, sales data, and ask AI to generate some statistics out of it. But now with agents coming into the picture, what we are doing is we are asking AI to generate a chart out of it, to visualize this sales data in a better manner, or maybe generate a report out of it, which can be actually put across the stakeholders or shareholders in a quarterly meeting. So these type of things comes into the picture when we are using the generated information to take a course of action. Now, what happens is right now there are so many tools out there which are trying to uh, claim that a single agent can do everything. And I think that's where the problem arises. Like 90% of the tools that we see on LinkedIn or anywhere else does not make up to production. And the main reason is that they are trying to do everything at once. So my advice is, from what I have experienced, is that instead of focusing on the breadth, we focus on the depth. That means that we build vertical agents. Now, what I mean by vertical agents is that we are not claiming that a single agent can do everything, but we are building specialized agents, one agent that can do one task, but very perfectly. And then we can, of course, have 10 different vertical agents who work simultaneously in harmony to automate a lot of your tasks. So let's say you want some kind of prediction system and you want a data science agent that can run across your sales data, that can run across all your sales and purchases, and comes up with reports like market basket analysis, or what are your top 10 products and things like that, which helps marketing team to put across the products. Uh, then what we do is we have one agent that only focuses on data pre-processing and cleaning. Then we have another AI agent which only focuses on prediction systems. That means using this pre-processed data to generate a prediction of which products might perform good, or what can be sales for next month and things like that. And then we have another agent that only focuses on using this prediction data to, let's say, generate visualizations out of it and convert it into a presentation. So now what happens is you have three different AI agents who are working simultaneously to achieve a task, to automate a task, that is complete data science and prediction system for your entire sales data. So that is something that is happening right now about AI agents. And uh, moving forward, so let me dive a little deeper into what are embeddings, and why do we need, like, what are the steps to actually embed the data and make it searchable. So as Tyler said, we can use services like Azure AI Search, where so I think that is one of the most easiest and fastest way you can build a production level RAG. You don't have to worry about underlying pre-processing steps. You don't have to worry about embedding your data. You don't have to worry about whether your data is searchable or not, and things like that. So I think there is very easiest way and the fastest way to build a production level RAG, and it actually works. Like we have tried that on so many different forms of data, and Tyler is already using it for a Fortune 500 company. But let's say when you want more control over your data, or let's say when you want to actually know what's happening under the hood, that's where you can build your own ingestion pipeline. Now, before diving into this, I want to show an example of what happens um, when you when you build your own ingestion pipeline. So let me can you see the screen, the slideshow? Okay, okay. Fine. So let's say here what we are doing is we have a chat bot which is for an organization, workplace organization, and this chatbot caters to employees for different types of questions. Now, let's assume that this chatbot, this RAG system, is connected to different data sources, and one of the user asks a question that how much time off do I get per year? Let's say this is an employee of an organization. Now, what happens is there are different documents and data sources which this chatbot system is connected to. And for example, we have two filters, or two contexts here. One is the official leave policy document, where we have information about PTO and what are the leaves that you get in an organization. And another part is a random Teams chat between two employees. Now, all of this is kind of indexed into your vector database. Now, what happens is when you ask a question, it might happen that chatbot picks up these as a context, the team's conversation between two employees, and generates an answer out of it. Now, what happens is this answer is inaccurate because the reference itself is inaccurate. And how can you control this? So that's where you need more control over your ingestion pipeline, right? Now, one of the ways to handle this is to use some kind of metadata filtering. And how can we do that is what we will uncover in a few. But what happens is, I know for sure one thing, that this question belongs to HR department of the company. Now, I have two options. One is that I can go across all the documents that I have in my data source and try to find an answer to this question. Or secondly, what I can do is, since I know that this question belongs to HR department of my company, I'll only go through the documents that are tagged as HR documents. And now what we did is we sliced the haystack even before starting to search for the needle. So what we did is we drastically reduced our search space, and this not only results into faster results, But what happens is there are less chances of hallucination now because you are not leading to inaccurate data sources anymore. So what happens is the team's chat between two employees is now no more into the picture. It is filtered out because it is not labeled as department equals to HR. And since I use this metadata filter, now the only source that passes as a context to my LLM is this one, which is the source of truth. And now I think my chatbot will come up with an answer which is very accurate. And this will, of course, be very faster because we have reduced the search space. So, like now, if you want to uncover that how we can actually build metadata and why metadata is so essential, we have to take a step back to analyze what are vector embeddings first, and how do we tag metadata with our data sources. So what we usually do is, since we have large amount of data which may be PDFs or Excel sheets or maybe our traditional databases like SQL and things like that. So we try to chunk our data in a way which is more manageable to use and make it searchable. And as we all know that AI models cannot understand text, we need to convert everything into numbers. Now, for this, we use some kind of embedding models which convert our text into vector embeddings. So, what it does is it converts your text, which is, let's say, Manning is great. It goes through some embedding model, which is a very complex AI model, which has a lot of mathematical calculations inside it, and it comes up with a vector representation of it. Now, why do we need a vector representation? Is because consider vector representation as some kind of a dot in a multi-model graph, and all the words and sentences within your data sources are all the different dots uh, in this multi-model graph, like multi-model space, vector space, which we call vector space. And what happens is two dots lying very close to each other means that they both have similar vector representations, and they might also mean something similar. So if you try to calculate a cosine distance between these two dots, it would be very less because it means that they are somewhat related to each other. So for example, words like good and awesome would be very near to each other in the vector representation because they both kind of mean the same. So this is kind of a general idea of embeddings. And what we do is we first chunk our data and then convert it into vector representations, and then we store it into a vector database. So now the question arises is how do we chunk our data? Now, as I said that we might have different data sources. So what we do is we have to build a different ETL pipelines for all of these sources. ETL stands for extract, transform, load. And here what we do is we build a separate ETL pipelines for all the data sources that we have, because data ingestion is the most important part of the entire system. Because if you don't ingest your data correctly or properly, and if the breakpoints that we create within the data is not correct, we might miss a lot of context information. So we have to build different ETL pipelines, and then we convert it into chunks. We pass it on to embedding models to further create vector embeddings. Now, as we said that we might lose a lot of information if data is not chunked properly. So the next question is how do we decide optimal breakpoints within the chunks so that the data is broken down in a way that we don't lose context and it is more manageable. So for that, we have a technique called as semantic chunking. So usually there are a lot of techniques out there like character splitting, paragraph splitting. So what they usually do is they split the text after some static number. Let's say after 100 characters there is another chunk. Or what they do is they split across different paragraphs, so one paragraph is one chunk. But what happens is sometimes two paragraphs are interrelated, or maybe a third paragraph is interrelated to paragraph number one. And if they are not interconnected, we might lose context, because while searching, LLM might only pass one paragraph as a context, and we lose information that was in the third chunk. So we come up with something called as semantic chunking. And what semantic chunking does is it compares all the sentences in a paragraph with the anchor statement. So we define the first statement as an anchor statement, and then we keep moving forward. We take another sentence and we calculate the semantic similarity with the first one. And then we take the third one, calculate the semantic similarity with the first one again. And whenever we feel that there is a change in meaning, or the direction of the content is splitting apart, that's where we know that this is a right place to put a breakpoint. So let's say, for example, in this example, we're talking about Sam, and Sam is pursuing masters in computer science, and he talks about the subjects that is studying and what is he currently working on. And then we talk about he likes to play tennis or go on hikes. Now, this is an optimal place to put a breakpoint, because we were first talking about its academics, and then we shifted towards his hobbies. So if we put a breakpoint here, we are not losing any context, and we still have a manageable chunk which we can use further for retrieval. So this is one of the ways to uh, chunk your data in a way that we don't lose context. And there are different techniques inside, like how to decide the threshold for this similarity scores and all of this, which you'll get to read if you read go through this chapter in detail. uh, One more thing that I'd like to cover is about metadata. So once we have these chunks ready and ready to ingest into the database, we tag these data chunks with some information so that we can filter them out. So as I showed you in the end in the example, that we filtered our data with department equals to HR, and what we did was we reduced hallucination and we reduced our search space. So this is a visual representation of, sorry, yeah, this is a visual representation of what happens when you perform metadata filtering. So let's say these are all your data points, and when you apply some kind of filter to it, department equals to finance, now your metadata filtered results are so less than your original data points. And out of these, you search the context. So what happens is you are reducing your search space. And one way to create metadata. Now, the problem is, how do you create metadata? Now, creating metadata is also something which is, a question for a lot of people, that since you have a huge amount of data, the question arises, how do you create metadata in a way that, uh, uh, you know, it can be, is there a way to automate this, or what can we do? What's the strategy here? So one way is we again use LLMs to create metadata. So what we do is uh, we have our, yeah. So what we do is we have our OpenAI client which receives the text chunk input, and then we have some kind of prompt where we ask LLMs to generate metadata filters out of this, and then we use the response that we get from it. Let's say we ask LLMs to generate keywords from all of our chunks, and we extract keywords from the response, from the OpenAI response, and use that as metadata for the chunks. But this can be expanded to many different metadata filters, like department, or uh, document ID, or access. So this brings an important point of access control. So let's say the chatbot that we talked about, a workplace chatbot which is connected to thousands of different data sources, and you ask the chatbot about what's the salary of the CEO of the company. Now, this is a question which is very confidential, and this should not be answered by the chatbot if you are an employee of the company. So what happens is, how do we filter this out? How do we tell AI to not search for this question, or to not search through this document, because this is a confidential document? But the problem is, if the board of director asks this question, then he should get an answer. So here there should be a way to restrict this documents for a particular person. So just like we use access controls within our traditional software engineering, we have to implement some kind of access control. Now, to implement access controls within vector database, we again use metadata. So what we do is, within the metadata tags, we can have one more tag which gives us user permissions. So which defines user permissions of each of this document. Now what happens is, when an employee asks the question, we use that metadata tag called user permissions to check if this user actually has access to this information, and we only use that document as a context if that user has access over this document. So this is an interesting way to implement access controls using metadata. So you see, metadata is I believe that metadata is even more important than data, because that's where the power lies. That's where we can control how we want to use this data. And of course, how you craft your metadata schema is again very important. And I think it's fairly as important as drafting your traditional SQL schema, because that's how you're going to search your data. So it purely depends on your use case. It purely depends on what kind of data it is, what kind of questions do you want to ask to your chatbot, and based on that you can create your metadata filters. Mm, And then what we do is we kind of ingest this into a vector database like Quadrant. In this example, we have mostly used Quadrants, because Quadrant vector database, because it is very easy to use. But what we do is we initialize a Quadrant client, we check if the collection exists or not, and if not, we create another collection, and then we initialize the point list, and we iterate over all the chunks that we created, and we embed it and push it into the Quadrant database along with the metadata. So this metadata gets stored along with the data points, and then we can use that vector database further at the time of retrieval to search through this. Now, let's say we ingested all our data into the vector database, we have all the metadata filters. But when you ask a question like, what was the quarterly sales report for last month? The problem is, how do we know which filter to apply? We don't know the metadata schema. So now the problem is, how do we generate the filter out of it? So for that, one way is, when you go over the agent that kind of classifies the question into one of the triage, the query triage part, this one, the query triage part, where we actually decide what to do with the query. That's where we add this metadata schema that we have already created. So we pass this metadata schema along with the user input, and then we ask LLMs itself to generate a filter out of it. So LLM will say that, okay, for this question, I think the filter you should use is department equals to finance. And then we pass it on further. So we are already filtering out only the important documents that we want to search over. So yeah, I think that's all about metadata and the overall flow of ingesting your data till retrieving it end to end. Yeah, that's it. That's it from my side.
Amazing. Thank you for sharing.
Yep.
So,
Thank you.
so let's open Q&A now. I'll be monitoring chat, and you can unmute yourself and ask questions. And personally, like I can start while people are getting like, I ignored Azure AI Search for the longest time because I thought they just named Azure Cognitive Search and added AI in there. But
They did.
mm, but at one point, like they also can do a vector search. Like why both Quadrant and Azure AI Search? Like, uh, can you walk us through that?
I'm sorry, say that again.
So you're using, I thought like that Azure AI Search can do vector search as well, but you're
Yes.
also using Quadrant. Like, is it for different type of data? How does that, how do they overlap, compete, or like, do you need two vector databases?
I have very little experience using Qdrant or Quadrant. Darshil can talk about that. I can talk about AI search. AI search, it has both a vector search and it also has text-based search. So it's got somebody told me that it's based on Elasticsearch.
Yes.
And it's just it combines the best of both worlds. It does something called hybrid search, where it searches by text and also by vectors. So I think that's part of why it works so well for us.
And it
So
does re-ranking at the end, what I hear.
yeah, so to answer your question, Daniel, we have two different approaches in our book, where we first talk about, as I said, the easiest way to build is to, the easiest way to build enterprise RAG is to use some kind of Azure AI search or any other search managed search services. And Tyler is right. It uses a combination of BM25, Elasticsearch, keyword based search, as well as vector search to give you the results. But if you want more control, then this is one of the ways where you can build your entire pipeline. And that's where vector database comes into the picture. So if you're
I see.
using managed search services, you need not use any quadrant or any other vector database.
Okay. And then you were talking about pipelines for indexing documents, but documents keep changing. And I know Azure, you can trigger that. What are the best automatic triggers that work for your type of data where you're using Azure AI Search, Tyler?
Oh, well, so Azure AI Search has a built-in trigger where if your database changes, then it will update your search using just the data that changed. However, setting that up is a nightmare, and we have not been able to get it to work. So I suggest doing your own code. Like you can do it in 5 lines of code. It just says check for new data, check for data that has a timestamp greater than last week, and then import it into AI search. So that's just how we do it. Just if data changes, then we import it in. We put a timestamp on everything for when it's uploaded.
So that's enough questions for me. Like, let's see. John White has a question. Darshil, how do you settle on approach you landed on regarding introduction of metadata? What were the other methods reducing hallucination that you tried and arrived to this? Both
Yeah,
of you can answer.
I think it was a very iterative approach. We tried a bunch of different things before coming to that. I think most of it was around, specifying a data source. So initially, what we tried is we tried to only answer the question based on official set of documents. But now this is kind of, uh, uh, this is kind of a face off from accessibility because people wanted to search through their chat history. People wanted to search through the documents which may not be official ones. So that's where we thought that there should be a way to kind of filter out and let AI decide based on the user query that which source to choose. And then we landed up that how can we specify the source? So that's how metadata came into the picture.
I also wanted to point out something. Darshil is being very modest. He invented that method of focusing on metadata. It's called AutoMeta RAG. And you can look it up. Qdrant is a big fan of that. So John, as far as reducing hallucinations, I put temperature at 0 because for me that makes it less creative. And when you're doing RAG, you do not want a creative AI.
Got it. Yeah, that makes sense. I thought the way Darshil explained it, what he was doing, I really saw that as a really user centric way to, solve that problem. Because, like you said, you're not having to force them into a specific way of asking the question. It's a lot more, user friendly. So I thought that was really good. But yeah, I understand what you're saying, Tyler. That's awesome.
Great. Okay, so Luis, can you discuss any alternatives when something as a service may not be viable? Vector database feature store model serving. Can you discuss the relevant system design characteristics when trying to minimize operational costs, service embedding models, data volume quality? Well, I mean, those are some really good questions. I think Darshil might be okay. System design characteristics when trying to minimize operational costs. It's a really tough question. I think everything. A lot of the times, open source will be the cheapest. Like if you're able to run something on premises, then that'll be cheaper than renting something on Azure. But scaling up might be more difficult. Might be just as expensive to run stuff on premises because you have to buy the equipment. Any alternatives when something as a service may not be viable? Elasticsearch. I think I don't know if this is true or not, but I was talking about Azure AI Search online on Reddit, and somebody told me that they used to work for them, and Elasticsearch does all the heavy lifting. So I've been trying to learn Elasticsearch because of that. I don't know if it's true or not.
Yeah. I think one another way people are trying to optimize this is, and this is for the people who don't want to migrate the data from traditional SQL databases or MongoDB to vector database. So what they do is they just use AI to generate an SQL query out of the user query, and then use that query to query their traditional databases, get the information, and pass that as a context. So the entire part of using a vector database gets out of the picture.
Yeah, that's another thing that you can do is just have AI agents write your SQL queries. If you can do that quickly, then that's fine. Okay, so there's a question for you, Darshil. You spoke about semantic chunking, but when it comes to Excel or spreadsheets, how do you do chunking?
Yeah. I think there is no way to implement some kind of semantics into the Excel sheets. So the only way is you kind of one thing that I did while working with Excel sheets. So what I was doing is I was building some kind of uh, stock analysis system, and we had a lot of company fundamental information in the form of tabular data. So what we did is we used AI to convert the tabular data into statements. So what we did was we generated things like what has been the trend of the company, what has been the sales growth of the company. So we just converted numbers into sentences, and then we know how to play around with sentences. So that is one way to use. But yes, again, playing with Excel sheets and spreadsheets is still difficult, and we all are figuring out how to chunk that.
So what we do at my company is for like SQL data, and you can do this for Excel or spreadsheets too. What we do is we turn each record into a string. So like instead of the column names and then the values, we would say the name of this product is product XYZ. The weight of this product is blank. The the value of this product is blank. And so then we turn that record into a string and then we embed it, and we find that helps. Question about query triage. Is that sort of code block within the solution or LLM itself does that work? Yeah. So the query triage, I'm sorry we didn't explain this more thoroughly. It's as simple as can be. It is just a call to an LLM. The prompt is the user has given you a question. Please return what kind of question it is. If it's about a product, please return the word product. If it's about an order, please return the word order. Or if it makes no sense, please return the word clarify and ask a question. So it's just a prompt that we send to an LLM along with the user's question. And then when it comes back, if it's the word product, then we know, okay, we have to trigger our product agents. If it's order, then we have to trigger our order agents. And if it's clarify, then we just send it right back to the user.
Yeah.
Does that make sense?
It is
Brilliant. That is brilliant what you did there.
Darshil, I had a question around so would the agents like the LLM will they be trained with those documents or every time it's only going to be a search? So what I'm kind of trying to understand is say if you have a data which is constantly changing, in the case like documents, they don't change frequently, right? But say if you take an e-commerce for an example, right? The data always keeps changing constantly. In that case, how it works.
Yeah.
Like be
Uh,
up to date or
yes. So in that case, what we do is, of course, first of all, we never train the LLMs because that opens up an entire new vertical where we kind of fine tune an LLM on our data, and this only comes into the picture when your data source is too specific or too niche, like something which is purely very much uh, related to some medical terms or things like. But I think general purpose uh, LLMs are now trained on everything and anything. So training on specific data source does not comes into the picture. But when you are dealing with something that keeps on updating frequently, so what you do is instead of building an ETL pipeline or a part of ETL pipeline itself consists of a way to fetch the latest information. So let's say if you are relating to the source of an e-commerce website, then your scraper itself has to be the pipeline has to be effective in order to fetch the latest information from that website and use it as a context to the LLM. So another way is what people usually do is one of the metadata filter is the last updated date or the date of creation. So when you want to ask something that only answer this question based on information after 2024, that's where this filter comes into the picture, and it filters out the documents that are dated after 2024.
Yeah, that makes sense. That's pretty helpful. And do you think we can make so for a constantly changing data, do you think that still the vector DB and the Azure AI search would be a best way to go with, or are there any other alternatives that you would recommend?
No, I think you'll have to go through the same, because there is no other way LLMs can search for context without using
Mm.
a managed service or vector database. So the only difference would be that in other cases, ingestion pipeline would be something that we do offline, like that we do before inference stage. But in your case, maybe the problem would be that we will have to perform entire end-to-end pipeline dynamically in runtime. So we'll have to fetch the data, add filters, push to vector DB, and then extract information out of it.
Makes
For
sense.
dynamic transactional data, wouldn't function calling interface be better than using a RAG model?
Yes, so that depends on, like, there may be a scenario where you also have to fetch information from your existing data sources as well as this websites. So that's where the query triage and AI agents come into the picture, where you dynamically decide which route to choose to get the context. I hope that.
I don't know if this helps. Like, I didn't have a real-time streaming data cases, but DataBeam used to be good framework, and Flink is one of the execution environment. Google Dataflow has something. I'm sure they're not just saying on the side that they're adding some kind of streaming windowing techniques to index. So search that.
Yeah, yeah, yeah.
Feel free to. You don't have to type in the chat. Just chat here.
I have a question. It's easier for me to talk than to type. So I think this question is for Tyler, but maybe it's for you guys as well. As you have a RAG pipeline, right, and you are improving it and you're making it better and better, what are your evaluation methodologies to figure out, if your new RAG, because you may be changing models, you may be changing the vector databases, all these hyperparameters when you're tuning it. How do you actually figure out this, whatever the new one is better than the old one? If you can talk about this a little bit.
Well, that's a really good question. I use the same prompt for everything. There's one product, and my company has 5 million products. There's one that I picked. It is 4HP5 ON-S. And so then I will try a search and I will put that in and I will run it. And if that search result is not like in the top 5 results, then I know that something's wrong. I need to try a different search service, or I need to change the parameters.
Okay, I see that, but it seems more like a very manual process, right? If you retrain the RAGs all the time, I guess you would have to automate this in some way so that you have like exact metrics. How would you actually do that in automated way so you don't have to look at it?
I think what you can do is you can create a test data set out of your entire data, and automate the entire process, as Tyler said, to look for if that is within the first 5 results or not.
Yeah, and also do evals. In the book, in chapter 2, we talk about doing automated evals kind of as unit tests or as end-to-end tests.
Great, but that's only one part of the solution, right? One is to find out what are the most relevant documents, but the second one is to construct the answer, right? So that second part, how do you actually evaluate that second part? Because it seems like more difficult to do.
AI is really smart. It can pick out what's relevant and what's not. Like I said, we at my company we search like 10 different databases. Each database returns like probably around 3 answers. So that's 30 different pieces of data. And then we have a prompt that's actually really detailed. So we have the information up at the top, and then we have this prompt that says, here's the user's question. Please respond in the same language as the user. And please answer their question. You are an assistant for this company. And then it, gives a short little well-organized response. So I mean, we just kind of, AI is really smart. It does it all for us.
Thank you.
Thank you, Boop. I have a question for you too, Boop, later.
Sure.
Who wants to ask next? We get compliments. Don't leave yet. I have to give you 9 free books.
Okay.
Next question. Hey, so is this interface chat or you have a phone calls? How do people talk to your bot?
Oh, people call the service representatives, and the service representatives use it. So there's an employee between the public and the chatbot.
I see. So like Mechanical Turk, helping employee look smart.
Yeah, actually, you could call it that.
Cool. Any other questions? Like I had a question about the chapters you didn't write yet. So for the performance testing tool, how did you arrive to that tool? I cannot even pronounce the name. We use K6.
Locust?
Yeah.
Okay. Well, I tried a couple of other ones, and Locust seemed like the easiest to use. I got really lucky with that one. Like I told you, I usually have to try 5 different tools for every one that works. This one was the second tool that I tried. So, and it worked, and we've just kept using it, and it's really good at what Locust does is it creates fake users. So you install Locust on your computer, and you say, okay, I want to simulate what it would be like having 100 users go on my web page all at once. And then, of course, things break. And then you figure out, okay, what broke? What do we need to scale up? And then, something else breaks. And so you keep doing that until there are no more breaks.
That's nice. Like everybody talks about JMeter, but like streaming is the problem. So I didn't ask right question where I was choosing the tool, but I'll try it. Thank you. Any other questions before I throw the free gifts? Please do the survey. Yeah.
Humans are greater than or equal to humans. Darshil, I agree with you. Humans are greater than or equal to humans. Oh, Satish said, how can this solve use cases for fraud detection for 100,000 documents? How can this solve? I don't know anything about fraud detection. I'm sorry. I would have no idea.
I think like it's easy. Like AI was before LLMs good at finding out edge cases, something that doesn't fit. So I don't think it should be hard. Like Google recently bragged, they kicked out 39,000 advertisers for fraud from ad networks with LLM. So it's a big use case, security and fraud detection. Everything that's weird. Like I have the prompt that when I'm transcribing YouTube videos, most of the nuggets are at the end during discussion. So I ask it to find what's unusual, what's different. And that may be fraud, that may be new knowledge. So
yeah, that's interesting.
Yeah.
I
think in that case, what we can use is something which is very counterintuitive. Like, in general, what we do is we try to find out vector similarity, and the higher the score means that it is very much familiar. But in case of frauds, usually what we try to detect is outliers. And in that case, we may try to filter out data points which has the least similarity with the rest of it. So if there is a data point which lies too far from the cluster, that is an outlier, and we need to analyze it further to see if that is a fraud or not. Like just a general approach.
Awesome. Thank you.
So I just dropped 10 codes, like 9 of them are valid. So enjoy it. Manning was really generous this time. Normally we get 1 title for free. Now 9 of you will be able to read the book for free. If you are not lucky, then there is 45% discount I mentioned at the beginning, but I just realized it's been a year since they gave us, so you can use Stuart's account, and then I think these are your links, Manning links, where you can attribute to the writers.
I thought you were going to raffle them off. It's just a free for all.
Like, I don't know what happened, but Courtney really likes us, so she was, take 10. Like,
Okay.
I know 9 are working for facts, so I cannot guarantee 10.
A person had a question. Let me see. Satish. Satish had a question. How much does the, oh, I'm sorry, it was Luis. How much does the book discuss incorporating agents into a RAG system? Chapter 5 is all about that. I just finished chapter 5 today, and it will be published next week. So just, yeah, it's going to be out next week, and it'll tell you everything. It'll tell you more than you want to know.
Any other questions? Like, we don't need to stay like longer if you didn't vote, or
Hi. So I had a question related to something that I'm trying to build a company out of. This is particularly in the insurance space, and we're trying to essentially model and collect all the data from you have loss data, you have data from say natural catastrophes like floods and all these sorts of things, wind, earthquakes, such kind of thing. And you also have a lot of geographical rated data, textual data. Uh, I essentially all this is related. So this is essentially a graph database. How would a RAG? How would you structure a RAG? Or how would you create a RAG that essentially then uh, and this some of this is historical data also because loss data is historical data. How do you construct a RAG out of mainly a graph database at the back end? I know it has to have a vector somewhere, but how do you do that?
So
I know this might be a vague question, but if you could follow my drift.
so what are the expected questions that you are expecting
So
from?
so the good point. So the questions expected would be somewhere related to what is my risk of if somebody asks for a policy in a particular geographical area, what is the risk, my risk to what amount of risk am I holding? Um, because I did then need to price the policy around that. Like, I need to price the premium around that, right? So an actuary might do that essentially. An underwriter might do that. So that's a question. But then he has to have all this data in a graph database, and some of this could be real time data, some of this could be historical data. It's kind of a messy
Yeah,
situation. Uh,
I think.
would a RAG work there, or how would you structure it? Sorry.
Yeah, I think in such cases you would have to, like just think like a human. Like let's say you are an insurance expert. Now, what would you do in this case is you would try to analyze the situation, and using your knowledge, you would come up with something like that. Okay, in this case, usually we provide no coverage, or we do provide coverage, and this can be the amount we can reimburse. So what you do is you kind of create a knowledge base out of your experience. And similarly, in your case, what you can do is you can use all the previous events that has happened and all the messy data that you have to come up with a policy document. Now, this policy document keeps on updating based on new events that occurs. And
Oh,
using the
interesting. Okay.
policy document, you can question users' queries in real time.
So essentially, you're saying creating an ideal policy document for a particular use case,
Exactly.
and there'll be many such policy documents because there'll be many such things, and then you index a new policy with that. Essentially, what you're saying.
So basically, create your own source of truth.
Correct. Correct. Yes. That's a good approach. Thanks.
Darshil, like about AutoMeta RAG, I don't think you advertised it properly. I ignore it, I must admit. I was like, come talk at the meetup, do not market another framework. But I'm now curious. Can you?
Yeah, sure. So basically, the way AutoMeta RAG works is I'll show you the uh, share my screen quickly. Yep.
you
Can you see my screen?
Mhm.
Yeah. So AutoMeta RAG is kind of a framework to automate metadata generation, and it does that at all three levels, like ingestion, and also at the inference, and then also while putting this data into the vector database. So what we do is we have the raw data, And we provide two things as an input. One is the data description, where you provide information about what this data is, and as uh, someone Nikhil just gave us an example of the insurance policy documents, right? And then we have a list of probable questions that you expect from your users. Now we use all this information and pass it to the LLM to generate the metadata schema. Now, this metadata schema are at two levels. One is the file level schema, and another is the chunk level schema. So the file level schema is attached to all the chunks, and chunk level schema is unique per chunk. And we use this metadata along with the documents and store it in a vector database. So now the entire metadata generation process is automated, and the schema is also generated by the LLMs. Now, once you have your vector database ready with the chunks, what we do is we pass this schema to the LLM at the time of inference to create a metadata filter out of it. So when user asks a query, we ask LLM that which metadata filter to use here. And once we get that filter, we use that to conduct a semantic search and filter out the data points. So the entire process that we discussed can be automated. This is an open source repo. I also have a blog on this, and here's the repo. We have a notebook, the Python notebook, which has all the prompts and everything in place. Oh, sorry. But you can download this and use it. It's just a different version. And we are also coming up with a UI, the basic Streamlit UI out of this to use, but it is still, not ready to publish, but it should be out very soon. You just have to add your quadrant access tokens, OpenAI access tokens, and all the prompts and everything is in place.
Perfect. You just used my choice, which vector database to use. Like I was looking at Vavit, but this is a good one. And then I assume because you're in Azure, you're using OpenAI's models. Have you tried models with larger context window from Google, Gemini, or have you experimented?
No, I think I have used Claude for some use cases. Claude is really better in code generation, but other than that, I have not experienced any other.
This is GPT-4o, I assume.
Yes, GPT-4.
It's a good one. Okay, I'm done with my questions. Anybody else? So we gave prizes. Feel free to enjoy like the book and the authors here. So if you have any questions, we're going to be 8 more minutes. Don't be shy.
Vuk, I have a question for you, Vuk. So you said that Meta has around 270 models, which they use to predict who to serve ads to. I was wondering, are all those models deep learning models, or are some of them classical machine learning?
All of them are deep learning models. There are few models that are what do they call them? The scaling models, basically, that once you get the model to produce the data, it use some scaling to actually adjust it. So we call them adjuster models. But yes, all of them are deep learning models.
Interesting. So do you average the results together, or is it like you use this model for this situation?
Basically, you use this model for this situation. So there are models for Instagram, there are models from Facebook, there are models for WhatsApp. And within those, there are like conversion models, there are, click rate, probability of click models. Then basically also there are some other models that, for example, that choose basically the input is like everything about you, for example, and about the product, and the model predicts the probability of a click, right? So once you actually go in there on Instagram, there's about 1,400 pieces of data about your behavior, who you are, what you do, how often you click, what do you like, and things, where are you from, and things like that. And then there are separate models that generate the candidates, right? So there's a model that can give you the probability of a click, but you cannot really run that in real time. 5 million products against you, right? So then there are some models that generate maybe 150 best candidates, and these candidates are being evaluated in real time, and then there is also all kinds of like auctions that are happening in that basically a half a second is what the SLA is, or 400 milliseconds before that you have to get the answer, right? So that's basically how it works.
Okay, that's amazing. I'm going to advertise the book on Facebook now.
Yeah, you should. I'm actually, I'm not even, I don't know what the advertising, how to optimize the advertising on Facebook. I was just, dealing with the models, but I'm sure there's an entire like ecosystem of how you can optimize all that stuff. I think maybe Instagram is probably a good, but I guess you have to be careful, because it can also cost you a lot, and you have to find some professionals to optimize how you're going to use your advertising dollars.
And can't you just put our book on top of everything?
I'm not there anymore, but even if I was there, I couldn't.
Yeah, just leave our book around.
I had friends asking me all kinds of stuff like, "Oh, can you just find out my girlfriend's, Instagram, what the messages are?" But I couldn't even do that, because to get any individual records, you have to like log into the system and say why you need them.
Yeah, well, I mean, Vuk and everybody else in this call, feel free to reach out to either me or Darshil. Vuk, I know you're working for, was it Bank of America?
Actually, I was out of work for a year. I took some time off. I had my own startup, back in Serbia. So I spent there like 6 months. But then I figured I want to come back, and do something. I didn't feel like running everything you have to run within a startup, buying furniture and dealing with like legalese and stuff like that, So I decided to go back to the corporate world. So I'm starting with Bank of America next week.
Okay, well, great. Feel free to reach out to me and Darshil if you need any help or advice.
Okay, I'll connect with you guys on LinkedIn.
Okay, and same goes for everybody else here.
Thank you so much. It's a really powerful combination, two of you, depth and product management and handling user expectations. I'm really lucky to meet you. So thank you for visiting us.
Yeah, thanks both of you. That was excellent presentation. Great discussion.
Thank you, Daniel, for having us. All right,
You guys,
All right.
great.
Good day, everyone.
Good night, guys.
Everyone, thank you.
Thank you, everyone. Thanks.